Okay, we start with introduction. Our project involved crafting a proposal to evaluate feasibility of a 5 years project to establish a new community college in Johor. Analysis of project includes history context, life cycle cost, WBS, and benefit cost ratio. And lastly, the objective of proposed project is to get insight into maintain the financial position and determine the most effective approach for successful completion. Next, for the company profile. First, Gamuda Berhad operates in the fields of engineering, property, and infrastructure. It was established on 6 October 1976 and a listing on the main board of Bursa Malaysia on 10 August 1992. The founders of Gamuda Berhad is Kun Yi Ying and Lin Yun Ling. The company is headquartered in Petaling Jaya, Selangor, Malaysia. Gamuda Berhad aims to lead the innovative solution for large-scale public infrastructure and property developments. The mission of Gamuda Berhad is to deliver innovative infrastructure solution and premier township. And next, Gamuda Berhad is one of the largest infrastructure companies in Malaysia. Gamuda Berhad has worked on key transportation projects like these MRT lines, highway, airports, and tunnels. And lastly, the company has also involved in the development of water treatment plant and dam. For the project background, first, new community college being established in Taman Bandar Batu Pahat, Johor. Because the location chosen has economic soil and stable rock geology. Land has a flat surface between 0 and 15 meters above sea level. Field observation and document analysis provide valuable information. And the location is positioned 3 km from Batu Pahat and 20 km from Senggarang. Strategically significant as it lies on the main connecting the town to Senggarang.
The benefit cost ratio is important in cost benefit analysis and provide a concise summary of costs and benefits. BCA can be measured in monetary or qualitative terms and helps evaluate the potential positive net value of a project. BCA exceeding 1.0 indicate favorable net value. Cost benefit analysis compare economic advantage and disadvantage of project or investment. The analysis evaluate feasibility, compare initiative, appraise decision, determine government investment, and assess resource utilization and environmental changes. The objective of benefit cost analysis is to enhance social well-being. All benefit cost analysis address problems that need resolution. So on this part, project benefit provide opportunities for youth to engage in higher education, give job opportunity, offer economic and education opportunities through training, provide sustainable building, save energy consumption, and overcome pollution. So for cost project, architecture, design of building, operation and maintenance cost of building, ensuring cost of building, construction cost of building, sophisticated equipment cost, material cost. And then last, this benefit project, loss of wildlife in urban area. So for this part, the value conventional ratio with present workforce side A, we get 4.187. It is more than 1.0. So for modified value, we get 4.708, also more than 1.0. So next, for side B, the value conventional ratio with present workforce side B, we get 4.131 more than 1.0. So for value for modified, we get 4.692, also more than 1.0. So since the benefit cost ratio for both sides A and B is more than 1.0, signifying that the benefits outweigh the cost, it is recommended to proceed with the project at both locations. Nevertheless, site A was selected due to its superior B advantage and disadvantage ratio compared to site B.
Next, I will continue for the presentation of analysis on the company performance. For the life cycle costing, the life cycle costing (LCC) approach is used to calculate an asset total cost during its entire life cycle, which is include initial capital expenditures, maintenance costs, operating costs, and the asset's residual value at the end of its life. For initial costs, the upfront cost of an asset include planning, expert service, legal and regulatory fees, insurance, land, material, and building expenditures. Developers may view this initial cost as the most significant outlay for a project. These products are placed within a broader cost framework through a professional life cycle analysis. And next is survey costs. Developers often assess these costs in a constrained amount of time. Conversely, long-term, cost-effective company success depend on an understanding of the pattern and structure of a facility long-term service charge. And the next one is preventative maintenance costs. Downtime and lost revenue are often associated with repair costs. In the industry sector, preventative maintenance is frequently employed to avoid unanticipated income loss. The same strategies can be advantageous for a long-term construction asset plan. Next is operating costs. Although running expenses are typically included in project feasibility assessment, a life cycle analysis can help to better understand how operating costs are rising. This understanding is critical for long-term profitability. And the last one is disposal costs. For increased profitability, buying company asset is still essential, but you also need to have a well-defined exit strategy. Early in a project, insight regarding this disposal cost is valued over the long run. So the below is a life cycle costing graph, the figure of LCC phase and cost appointment. Next is the sample of building construction from the Gamuda Sedia Berhad. At the acquisition phase, insurance, tax and financing is about 25,000 ringgit. Land acquisition is about 10 million ringgit. For architectural and engineering design is about 5 million ringgit. And materials and also equipment is about 25 million ringgit. For operational phase, the which is about 120 per person per day. For utility is 70,000 per year. Maintenance and required repairs is about 1 million ringgit per year. So if the total of workers is equal to 100%, so the calculation is 100 ringgit per person per day times 22 working days times 12 months equal to 31,680 per person per year. So for the variable cost formula is VC equal to AQ. So the answer for VC is 31,680 per times 100%. So the total VC is about 3,168,000 per year.
Hi, my metric number is CF210050. My name is Farah binti Rosli. So for the problem solving by using the principal engineering, there are 7 steps. Step number 1 is develop the alternative, which is our problem is the number 5 is crack in the foundation. Number 2 is building code change, which is the proposed alternative is number 1, implement a preventive maintenance program. The number 2 is perform a cost benefit. So to focus on the different, this is based on the implement a preventive maintenance program based on life cycle analysis and historical data. And number 2, it perform a cost benefit analysis. So number 3, use a consistent viewpoint, which is for implement, we use a regularly inspecting, extend their lifespan. And the number 2, the perform benefit, we compare the cost of renovation or replacing outdated facility with the potential benefits, improve functionality, efficiency, and compliance with the regulation. For step number 4, use a common unit of measure. Firstly we comparing different service across the department. Then number 2 is we demonstrating value to stakeholder. Step number 5, consider all relevant criteria is we review again all the criteria that we have been choose. And step number 6 is make uncertainty explicit, which is they had advantage and disadvantage. And lastly, the revisit your decision is where the decision to implement either of these solutions require careful consideration of both advantage and disadvantage and alongside specific organization and financial constraints. By performing throughout the cost-benefit analysis, involving stakeholder and seeking professional guidance, college administrator can make informed decision that optimize resource allocation and ensure the long-term sustainability and well-being of the college community.
The last part in our presentation is conclusion. In the end, the cost-benefit analysis for this university project seems more sound than it needs to be. It suggests that the estimate cost of the project is less than the estimate benefit. Economic analysis often considers projects with a benefit-cost ratio BC greater than 1.